Hey guys, John back again. And what you see before you is obviously a Cold Steel Natchez buoy that's been disassembled. And I realize I'm coming in late to the party because these knives have been out for quite a while. And over the years, I've heard a lot of concern, a lot of criticism, and some smack talk and other things on the internet and in person about the cable tang. I picked this knife up on eBay pretty cheap because it's a used knife. It's an old SK5 knife. It's no big deal, but the Natchez Bowie's always been one that I kind of liked, and I'd worked with it a little bit with just loaners from other people and things, and I figured I'd pick this up. And when I did, I noticed it had a little bit of a rattle in the grip, and I posted a quick video on that, and I went down and drilled 2 holes in this nut in the butt cap and was able to unscrew it. So I thought I was just going to tighten it up, but I said, well, I'm just going to see if I can dig into this knife. And I was disappointed that I was able to dig into it. We'll get into that, the reason why I was disappointed later, but let's look at this knife. People complain a lot about the cable tang on this knife. I'm not as concerned with many people about it because, to me, this is just a modern version of an old riveted sword tang. And I showed you last year, I think it was, or earlier this year, with the Ames cutlass blade, the relic blade from last year. I guess it was 24. That it had a scarf weld of a piece of steel onto a piece of iron to form the rest of the tang. And people have done that in various ways over history. One way that it was done with broadswords was you had a stub tang, and you had they would take which was steel, and then you'd forge a shorter iron tang, and then hot punch both pieces with 2 holes, and then rivet it through. And that riveted tang stood up to all of the stress that a sword gets, a two-handed sword in some cases gets, with a blade that's measured in feet, and there's a lot more leverage and a lot more stress on that tang from a sword than it is a bowie knife. So if you do a riveted tang with a knife, I would think as long as you did it correctly, didn't have any space in between the riveted surfaces, and use sufficient size rivets, I think you'd be in real good shape. What Cold Steel did is they drilled a hole into the butt of the tang here, inserted the piece of cable, and then if you look at these 2 surfaces here, some kind of a press, probably a big hydraulic press, crushed that down so that cable wouldn't come out. The same thing with this threaded portion here. They inserted 3/4 of an inch of that cable in there, and then pressed it down so it wouldn't come out. So that is a pretty substantial amount of construction there. So that's not what I'm worried about with this tang. What I'm worried about is the same thing I'm always concerned about, this tang transition. Because look at it. This tang right about here is about 1 inch and 3/16 wide. This tang is about 1/2 inch wide. So it drops over half of the width of this tang abruptly. And that tang should be at least 1/4 of an inch wider, and preferably 5/16 or 3/8 wider. So just leave 1/16 of an inch on either side to fit that guard. 1/8 of an inch at the most. And then feather that material back this way. It would add maybe 1/2 ounce, maybe 3/4 of an ounce. We're not talking about a whole lot of steel, guys. It's not much, but it would really change the character of this the way this knife is, the way this knife can be relied upon, even despite the cable tang. Like I said, the cable tang is not my concern. That tang transition is. Leaving the tang aside for a second, let's look at the rest of the construction of this knife, because it's not bad. You had You have the guard, and in order for it to be constructed with my method, you could cast. You have basically a 1/2 inch slot in this guard, and this guard very likely was cast. You could cast that 2 specs for that tang and not have to go through any machining at all. But you've got basically a socket for part of your handle that fits right in there. And your handle also has an extension here that fits into your butt cap. So there's a mechanical lockup between each part of this handle. It's held together with that nut. But if you look, and I didn't clean any of this, there's only epoxy on one side here. Right there. The rest of that guard's pretty much just clean brass. I didn't scrape any epoxy off it. There just was not any there. Inside the handle, where it's probably most crucial, you've got a little bit of epoxy on one side, not down to the bottom though, and not on this side. So this side, the side that you're looking at on your right as you look at it, doesn't have much epoxy. Let's see if I can get you to see that. There we go. Not much epoxy there. And that epoxy is used to eliminate the space between the handle and the tang. Same thing here. Pretty much clean. And when you have a narrow tang knife, particularly with a compromised tang, you want to fill all of that airspace. You want to fill all of that area inside of that handle so nothing can move, nothing can shift. That's why I was disappointed that I was able to get this knife apart, because even with the cable tang construction, I shouldn't have been able to pull that knife apart, because it should have been shot full of acroglass or something like that. And when I put this knife back together, that's exactly what I'm going to do. I'll probably soften the edges of this guard a little bit. I may or may not modify the handle, because I don't like the handle on this. It's just a little, I just don't like it. I might take this down a little bit here, and for my hand, this portion should have been back here just a little bit. I mean, you get a pinch grip, but that's about it. But I might modify the handle a little bit. I might leave it alone. The butt I might leave alone, but I might also drill a thong hole in it, because it needs one. I might also drill a couple of holes in the guard too, just for thonging it different ways. Then I'm going to clean up the tang, clean all the epoxy off it, and then I'm going to acroglass the entire thing, putting it back together the way it should have been from the beginning. And then, even with the tang that is less than ideal, not really the way I would build it, this will probably be a trouble-free knife for the rest of the time that I have it. And I'll be able to take it out in the woods and use it a little bit. Again, I'm not overly disappointed with the cable tang, and people have thrown fits about it and said, oh, it needs to be a full-length tang, it needs to be this, it needs to be that, while completely ignoring this area. And if this tang was as long as the cable is with that stress riser, your complaint would be shifted from here to here. Because how many times have you seen an actual knife breaking in the handle back here? It can happen, but it's not common. I see a lot more knives break right in here in the tang transition, right on those shoulders, right where the handle meets the guard. And that's a design flaw in not just this knife, but many, many different knives. I'm not saying Cold Steel doesn't know how to make a knife. They sure do. They make pretty good ones. But when I broke my Trailmaster back in the day, it broke right there for that reason. Had they done things just a little bit different, I'm not even saying change the heat treatment. That would be ideal. I'm not saying change the heat treatment, because I understand that things have to be mass produced. But if they just feathered that transition out just a little bit more steel, like I said, 1/2 or 3/4 of an ounce of steel, would have completely changed the character of that knife and the Trailmaster, and as well as the Laredo. But anyway, we'll take another look at this knife when I get it back together. I'll tell you what I think. See ya.